So the block flow diagram is to have the big picture of the project. So you have the units, mainly the description of the units and main considerations that must be done to build that project. When we talk about the process flow diagram, now we get inside the heating and material balance. So what are the purpose of the process flow diagram? Is to show the process, and now here we have the methanol reactor column process. So for instance, let's suppose that one of these boxes here or one of these units here is the methanol reactor. So we have here methanol reactor, and when we do a zoom in, we go to the process flow diagram. In the process flow diagram, the purpose is to show the main equipments that will be installed or that are in operations in the facility, and to show the heat and material balance. The heat and material balance can be shown in the process flow diagram, but it's not mandatory. Depending on the complexity of the system and how big is the system, the heating material balance can be shown or can be issued in a different document. So you will have a document for the process flow diagram with only the diagram without information about flow, pressure, temperature, and etc. And you will have another document issued to show the heating material balance with the streams, streams identification, with the information for flow, for temperature, pressure, composition of the stream, and etc. I have been working some projects, for instance, in hydrogen projects from SMR, that the same process flow diagram was supposed the same project was designed for different cases. So in this case, I had only one process flow diagram, like this one, for instance, but without any information related to flow, pressure, and temperature, because depending on the case, I had a case for using natural gas, I had a case for using off gas from another unit, I have a case to use naphtha. So in this case, I had another document with the cases separated by chapter, and for each kind of operation mode that I needed to evaluate, I go to the heating material balance document and I verify that which were the heating material balance and compare with the block flow with the process flow diagram. In this kind of process flow diagram, it's very important that you identify each stream, because here you can see that there is any identification for the streams. But when we detach the heating material balance from your process flow diagram, we need to identify, for instance, this is the stream 1. Some companies that I've been working on, instead of using numbers, they use letters. So it can be the NG01, or it can be only the stream 1. And when you get the heating material balance document, you will see stream 1, you will read your process flow diagram with stream 1, and you know where in each part of the process you are. And the main purpose of the process flow diagram is to show the heating material balance, or the reference for the heating material balance. But this document is important also because in some companies, maybe in most of the companies, depends on the company, it is a reference for building the human interface, human machine in the control room. So let me share with you. For instance, here I have an example to show you. This is a control room screen. So the equipments and the control valves, everything's the field running in operation, and the operator will be in the control room doing remotely control and also verifications and following up of the process. And your process flow diagram can be used to build this kind of screen if it is of course that as much complex is your process, more deviation will have from your process flow diagram, but it is a good reference for the automation team to work on the SCADA control, SCADA screen, or in the control in the human machine interface screen, in order that the operator understand better what is happening in the field. Another example that I can show you here is this one. Here you can see that I have a column, I have heat exchangers, I have vessels, pumps. So when I consider that my process has columns, my process has condensers, boilers, vessel separators. In this case, we have compressors also. We have heat exchangers, reactors. So these components must be shown in the control room. And as uh, not beautiful, but as organized you have your process flow diagram, easier will be to the automation team to get that as reference and build the human machine interface in the SCADA or in the screens used to do the operations, do the control.